Bears notes why quantum energy levels grow as n squared. You'd expect a ladder of energy rungs to be evenly spaced, like a normal ladder. But a quantum box's rungs fan apart the higher you climb. A particle trapped in a box can only be the standing waves that fit exactly. The lowest fits half a wave, the next a full wave, then 1.5. Its energy climbs as 1, 4, 9, 16 the squares. The gaps 3, 5, 7 keep widening. Let's turn that picture into a formula. Level n fits n half waves across a box of width L. So its wavelength is lambda n equals 2L over n. More half waves means a shorter wavelength. A shorter wavelength means more momentum, P equals h over lambda. And kinetic energy grows as momentum squared, E equals P squared over 2m. Substitute and the n lands upstairs, squared. En equals n squared times h squared over 8ml squared. The n squared isn't an accident. Energy goes as 1 over the wavelength squared, and the wavelength shrinks as 1 over n. Now let's put real numbers on it. Take an electron in a box 1 nanometer wide. Plug in the ground state E1 is about 0.38 electron volts. The second level is 4 times that, about 1.5 electron volts. So the jump from level 1 to level 2 costs about 1.1 electron volts. That energy leaves as a single photon. Its wavelength is hc over E, about 1100 nanometers. Near-infrared light set entirely by the size of the box. This is exactly how a quantum dot works. Shrink the box and every energy scales up as 1 over L squared. Smaller dots jump higher and glow bluer, larger dots glow redder. A quantum dot's color is just this formula made visible. So the rungs fan out as n squared because energy lives in the square of the momentum. And momentum climbs with every half wave you add to the box. Same picture as the short, now with the numbers behind it. Part of the Bears Notes series. Your turn, ask Claude, particle in a box, where the n squared energy formula comes from worked example. Thanks for watching. Find more Bears Notes at youtube.com/@NickBearBrown.